Good afternoon. Welcome to Cloud Next. This is Naresh, Head of Telco Analytics of Google Cloud. I'm joined by industry leader Matthias, Director, Networks and Transport from Telefonica Germany, and Josee, Loudiadis, Head of Analytics in Nokia and Business Line. Today we're going to talk about how telcos leverage AI and machine learning to build sustainable networks while reducing the cost. So before I hand over to Matthias, there will be a Q&A session at the end of the session. So feel free to pose your questions, and we're happy to answer. Over to you, Matthias.
Thank you. Can you hear me? Not yet. Now it's coming. OK, good. Good afternoon. So I hope we are not between lunch and keeping you guys busy, and I hope you will enjoy this session. So because we heard this morning during the keynotes a lot about AI, and we saw many announcements. And actually what we are going to talk about is a real use case, and it's something what is in reality deployed in our network. And actually it's something where we talk about a great partnership, where we talk about Google Cloud, how it helps us to enable new solutions, and where we talk about AI and how we brought all the three things together. So I think we are still fighting a bit with the sound, I guess. My name is Matthias Sauder. I'm accountable for the whole access and transport network of Telefonica Germany. And in this role, it's not just the thing about planning the network, engineering the network, deploying the network, but it's also making sure that we operate the network in the most economical fashion. And there we really care about ESG conformity. There we talk about our carbon footprint. And maybe it's interesting to know that we serve 44 million customers in the German market. And actually, almost 50% of those customers are young people. And as many of you know, young people really care about the ecosystem. They care about the environment. And so, as we are serving them, we also care about the environment. But we have some other challenges which are more, how to say, natural to us. It's our OpEx. It's our energy costs. So what do we pay? It's customer experience. But it's also our carbon footprint. And we faced some challenges last year. And the main challenge last year has been a spike in energy prices. So really energy prices skyrocketing. On the other hand, our traffic volume also still growing exponentially. So we were facing the last 2 years in traffic growth of more than 40 to 50% in our network. So actually, this is the point as a mobile operator, you could think, OK, I give up because my energy consumption goes up, my traffic goes up, and actually the energy prices are going up. So our operational expenditures and our carbon footprint also doesn't look that nice. So it's a nice. It's not on yet. Yet? Now it's better? OK. I hope it's much better. So it was a bit irritating, I have to say. So when you look actually at this chart, it depicts very nicely our challenge. So energy consumption going up, traffic going up, paying too much. We need to still to keep the customer experience and having customers who actually care about the environment, who care about our carbon footprint. So what to do about it? How can we cope with this challenge? And actually, we thought about this, and yes, we started to use the normal means of an operator introducing new software, introducing new features. But is this good enough? Is this really something what you should do today? And there we reached out to our partner Nokia and asked, OK, what can you offer to steer and control everything what we do in our network? And we reached out also to Google, asking, we have actually some systems already running on Google Cloud. Can we form a partnership to do something what helps us to cope with the challenge? And actually, we came up with this partnership based on a solution of Nokia and Google helping us to enable this solution. And so at the end, it's about the growth. keeping growth under control, keeping the carbon footprint under control, and introduce new systems to manage and to help us to cope with the challenge. And going ahead, and this is the most important slide here, I talked already about the AI, but the AI comes really at the end of the journey. In the beginning, it's using software in this case from our partner Nokia, making sure that you introduce software as early as possible to benefit from all the new features which the partner is developing, obviously. And there's a fun part of the story. Until beginning of last year, we were, I think, in the Nokia ecosystem, always world's last introducing new software, which is not the best place to be. And having the challenge which I outlined before, we decided, okay, we want to catch up. We want to do something completely different. So the first thing what we did, we introduced an agile cycle, introducing new software from Nokia. And I can tell you the last 6 to 7 software releases of Nokia, we were world's first, which is quite something. So that means first we got control about all the new features. Was the first step. The second step was to tune those features and also to make sure that we develop own algorithms like switching off certain layers in the network during nighttime, which is also nothing new in the industry. It's something what existed for many years, but I think we took it to the next level. And then we said, okay, what is the next thing? How can we control this without manual intervention? How can we make sure that they're not human beings sitting there and taking control about all the features and the layer switch off, etc.? And this is how the AVA solution from Nokia came into the game, and where we said, okay, this is something what we need to use, and it's up and running in our network for quite some months now, and it delivers 5% additional savings on the whole network. So it's a big thing. So 5% on the energy consumption of the whole network, it's a big thing. What we get here, powered by AI. And we want to go ahead for sure, new features. I mean, we had a chat with Josee before and said, okay, I need more of this. So I need another 5%, find something to make this happen, because it's for us super, super important. And yeah, now we could ask, okay, what has Google to do with this whole thing? It plays quite a big role there, because building this whole thing on-premise would mean building separate servers, building a test environment, so you double the investment because you need a test environment, you need to spin it up, and actually I can tell you that the solution based on Google is 2 to 3 times more efficient than building it on-premise. So this is a big thing what helps us. The other thing, it's time to market, because we were on a burning platform last year, so we had to find solutions to get this whole thing, traffic growth, energy consumption, energy prices under control as quickly as possible. And here it really helped us that we could, in weeks, spin off the solution, train the engine, and get it done. And I think this is also thanks to Google, something what really helped us. And it was also, the decision was made based on experience. Our SON systems, for example, run also on the Google Cloud. And so we knew what we are getting into. And I can just say thank you to the 2 partners, because they really helped us. And they help us also still to manage the carbon footprint, because it's also the better way to deploy in Google rather than to build on-premise, because also this helps to keep the carbon footprint under control. And with this thing, thank you to the partners. I would like to hand over to Josee. Questions you can ask at the end of the session. Thank you.
Thank you, Matthias, for being such a good partner for us to be working with you on this. So the first thing that we heard was that we save 5%, and this is fairly average. We've done this with several service providers. We have about 80 service providers we're working with around the world. We've been doing this since about 2018. So our first live energy saving was in 2018, when it was not in fashion to be thinking about this as much as it is now. But one of the things that is really, really important when we're talking about energy savings is that it comes, there's really 4 blocks of functionality that are really important, and 2 of them are using AI. The other ones are really domain experience, and this is where we came into the picture, because we are trusted to be able to touch these networks. It has hundreds of parameters that we can tweak, and being able to figure out which ones we need to tweak is also part of the solution. Closer. Okay. All right, so let's go take a look at some of these key things that we brought and that we use AI for, being able to augment what we're doing on the nodes. So the nodes by themselves are able to do like what your energy consumption at home, like your thermostat. You're able to set from this time to this time, I want you to bring down the temperature, right? We all do this at home. The nodes can do this as well, right? So they have settings where you could say during this period of time, I would like to be able to power down some of my radio. What we do beyond that, the very first thing that we do in AI is we open that window. We start looking at the traffic load on the radio and be able to determine and predict what is going to be the traffic at every given hour of the next few weeks. And when we are looking at traffic that is coming down, that gives us an opportunity to be able to power down some of the radio that we're doing, okay? So that's the first aspect of it. We need to be able to dynamically expand this window and to change it any given day. On the weekend, it will be different than on the weekdays. On certain periods of vacation, it will be different as well. So we need to be able to expand the window using AI with predicting when we can do things. The next thing that we do after that is we have multiple features on the node that we can tweak. We're leveraging the features on the node and we're saying, we would like to turn down the frequency. We want to shut off this frequency. And we will keep only one when we have a certain threshold of traffic. Okay, so we're going to shut down some frequency. We might shut down some antennas. Okay, so there's multiple antennas sometimes that are working in array together. We can shut down some antennas. We can shut down some specific slots that you are sending traffic in. Okay, and in addition to this, you might be doing some things like with 4G and 5G. Often they have their own frequencies, right? And you need to have at least one coverage area for each one of them. We coordinate and collaborate between them so that we could say we're going to use one coverage area. So we coordinate this on behalf of the nodes. There's also some of the additional things when you're looking at technology. You might be doing more frequency-based kind of slot, or you could be time-based slots. And again, they have their own coverage area. Usually, they're separate groups. We can collaborate and making sure that we are using only one group. So there's multiple features like this. We have about a couple of handfuls that we're doing over and above what the radios can do, and we do this multi-vendor so that we can tweak a little bit more. And you can see that little bit more that we can tweak gives us about 5% in the case of Telefonica. Now, the next block, so we said dynamic windows 1, all the different features that we can use on the different nodes in different ways. So that's our magic trick to be able to understand what each node can do, whether it's Ericsson or Huawei or Nokia. The next piece is really important as well, is how aggressive you want to be. I could power off the whole thing, and then you'd have no service, right? So where's the line at which you want to be playing? So you can decide to be a little bit more aggressive, sometimes maybe in non-urban area, and you decide that you're going to go further. Or you might decide to go a little bit less, right? Depending on where you are sitting in the different kinds of cells. And this is what we can set also in the system, is making sure that we are able, those thresholds on the traffic, we say, well, we're going to be more aggressive and do more power-saving features on different group of nodes types. So that gives you 3 blocks now to be able to play with. And when we did these 3 blocks, we got the savings that we were showing there. Now, there's one more thing that's really important, and it will be important to you guys, is when we are shutting down, we need to make sure that we are watching and making sure that we are not impacting the user experience. It's possible that we predicted, and it's a little bit off, so we need to be able to watch it in real time and making sure that we're not impacting certain kinds of thresholds of quality that we are looking at. And if we happen to be crossing these quality metrics, we disengage. And we need to disengage really quickly. We don't want to be sitting there and say, oh yeah, we're going to be thinking about it for 30 minutes and then disengage. We need to do this within a few minutes. Okay? So then we have the 4th block, which is really about watching the KPIs. All right, so here is the graph of what happened at Telefonica. So when you're looking at this picture here, you can see at the very beginning, when I'm looking, I'm just going to point at it a little bit. The very first window on the left, that's when there was no energy savings on the node whatsoever. Okay, so you could see the green line is a cumulative consumption of energy, and the blue line is the amount of traffic that was happening over that period of time. So as we introduced the nodes were able, so that's the thermostat, right? The analogy of the thermostat. The middle window is where we started savings. And you might say, I don't understand the middle window. Are you saving anything? Because the line looks like it's straight, right? But it isn't. Actually, when you're looking right in the middle, you can see a bump. You see the bump in the middle? So this is where the line was going. It was going a little bit more exponential. And then with the energy savings from the nodes, we were able to bring it down. Okay, so you can see towards the end of the windows coming back down. Okay? And then what we did is we turned on AI. And we turned it on at that in the last window. Then you could see the amount of savings that we were able to generate from that particular last window. Okay, once we started turning on all the different features that we had, including the thresholding and where we were going to be putting that threshold. And by the way, that threshold is generated by AI. So we look at it and we start learning the patterns. We say we should be setting the threshold here based on how aggressive or conservative you want it to be. All right, so this is what we achieved. So in total, between the node at 2-3% and 5% with AI, we were able to save about 8 to 10% overall. And then lastly, the deployment. We do both on-prem and cloud deployment for this solution. I prefer by a long shot to go on the cloud. It reduces the amount of time that it takes to deploy from several months, 6 to 9 months, to 1 to 4 months. This is what we can say. We can turn on the system, and if you're using the standardized capability that we have, we can turn on the system in about 3 hours. And that includes because now remember in our solution, we're on the cloud, but we need to touch the network. So we have very secure pathways for being able to establish between our cloud and the radio network so that nothing can get into play there. So this is a very secure pathway, and we can do this templated as well. So we have VPNs going across. And then, so that's the time to market. So we're able to go much faster. But in addition to that, we're able to be less expensive. Every time you're on-prem, it's like walking into a new cloud. I walk into DT, they will have a specific way of deploying a cloud. I walk into Verizon, I'll work into AT&T. Everybody deploys slightly differently inside. When I go and work with Google, I have one way. I can learn it once, and I can do it super automated. And then it gives me not only the time to market, but also the reduction in cost that it takes to go and deploy as well. And on that note, I'm going to pass it on to my friend Naresh, and you can tell us more about what you're doing, not only on the cost, but also on sustainability of the cloud itself. Thank you.
All right, thank you. Thank you, Telefonica and Nokia, trusting Google is your preferred cloud model. Right? I think, so while we understand the initiatives of Telefonica and the overall the sustainability goals, it's utmost important for us to bring the cleanest cloud, right? Google has been taking a big initiatives in terms of sustainability, and like we are running one of the most cleanest cloud since 2017. So we use 100% renewable energy resources, right? I think that even if you compare to any other hyperscalers, they would actually take almost 2025 to reach that target. So it's extremely important to use renewable energy resources and provide the cleanest cloud. So we use AI and machine learning, and also mostly the data-driven approach to actually maintain our cloud and also our data centers. So this actually ties back to the overall sustainability goal from our operators around the world, right? So what is so important here? Like if you see, the data center itself has gravitated towards providing more and more higher performance TPUs, CPUs, right? I think you heard in the keynote today, this morning. So we are adding more and more ammunitions and power to our data centers with this extremely high capable of TPUs and CPUs, right? GPUs too. So with the influx of just generative AI, now it's important to actually bring down the power of these performance units. So that is why it's, given the sustainability goals, while Telefonica is saving energy on the RAN side, we cannot be consuming more and more energy on the data center side, right? So it's a very important aspect that we provide the cleanest data center so that there is a huge reduction in the energy overall. And one of the other important aspect is the cooling mechanism, right? Like the heat dissipated around these network nodes today is actually requires a high cooling requirements. So you cannot simply turn on a high coolers and basically say that you're trying to save energy. So it's important to have some sort of a sensor-based mechanism where we actually ingest the data at an every 5 minutes interval. We go through our deep learning mechanism to actually effectively manage these cooling. So that way you will see the overall the energy saving is is completely, the energies are optimized and the data center runs at a very high performance rates. And most important thing, to build these kind of AI and machine learning models, you would need these core GCP services, right? I think Nokia has been leveraging some of these GCP services. While we are talking about all this BigQuery and Looker and like all of these great Google services, now the introduction of this Duet AI and stuff like that, it's very, very important to understand these services is extremely optimized, CPU optimized. Like basically, when the rather traditional lift and shift model is really not an optimized solution to run on cloud, but once we re-architect, once we use more and more native services, this is where you will see the complete optimization that also includes the energy savings as well. So this is great. But what's next, right? I think we are still in the journey. Like, we have not completed this. Like, this is not just one story to be told. We need to pass this back in terms of understanding how can we pass this into different layers when it comes to this energy savings. Maybe I'll pass it on to Matthias. Like, what's your plan? What's next?
I mean, I told it already before. I mean, we need more. We need more savings. But I think we need also to educate the ecosystem. Because there's one example, and many of you might know it. Networks are compared on the basis of benchmark tests. And when you look at those benchmark tests, it's always a comparison of who or which network has the highest speed, which network can differentiate based on speeds, on something, better voice or whatsoever. But I think our young generation demands something else. I mean, they want to have a most efficient network. They want to use the network whenever and wherever they want. I mean, this is not going away. Customer experience is still key. But they don't necessarily want to have the 1 gigabit speed. They want to have maybe the 10 megabit whenever they want to use it. And they want to have a network which takes care about the ecosystem, about the environment. And I think we need to develop this in the ecosystem to go away from defining just the network which radiates the most of energy is the best network. I don't think so. This is not what we should do today. It's really the network which provides the best customer experience in the most efficient way to customers. I think this is the best network today. And we need to work this out. And I think on the other side, I think the AI is not done. I think there is more to come and more possible. So our bets are on Nokia, Google helping. And I think we can do much more here to get to the most efficient network and to tell maybe next time a story that we achieved 10 to 20% savings because this is where we need to go. And this is also what we need to manage. And we need to find the right balance, customer experience, efficiency, carbon footprint, and having a good quality overall, and also telling and selling the story to our customers. At least this would be my demand. But maybe Josee has another opinion on it. I hope not.
Thank you. Now, there's more we can do. We talked about frequency, we talked about antenna, we talked about time slots. Tilt is another thing. So when you're looking at the antennas, you can start tilting the antennas and it will go further out or closer in, right? So you're able to play with this. But in order to play with this, you need to make sure you understand the user experience and the user experience at the detailed level. So this is one of the things where we're going next is really understand the user experience within a particular cell lit area and to be able to kind of adjust the tilt in real time. So this is one of the areas that's next that we're looking at. But we also want to rope in all of you. We want to be able to give you the information and the tools to be able to be part of this story. Because this is what Scope 3 is doing in ESG, right? How many of you use Duolingo? Anybody? A few? So in Duolingo, you have leagues. So you kind of go up in leagues, like, oh, you did really well this week, and you have a lot of points. We're going to put you in the Diamond League or whatever league is next, right? Now imagine if we could give you which one of the bands you're into as a consumer by comparison to the rest of all the consumers on the network, right? Imagine you are a 6, and somebody else might be a 2, and someone else is a 10. If you knew how you're consuming the network, because your phone is idle possibly right now, and then at some point there's going to be applications that are waking up the connection in the background. You don't see it right now, but it's happening. What if we could tell you, hey, you know, you have these applications that are really consuming the network. It's going up and down continuously. You could change some configuration. What if we could tell you, hey, you know what? You're currently watching this video at this resolution. If you went down this way, you could save this much on the energy. What if I told you that you are this far away from the tower? And right now, this call would be really expensive because the tower has to put a lot of energy towards you to power you because you're far away from the tower. Do you really need to make that phone call right now, or could it wait until you're a bit closer? Right? So there's some things that we can do and inform you about how you can do better usage of the network, reduce your consumption, be able to bring down your band into a lesser consumption so that you would be able to participate in the energy reduction as well. And what if a portion of that reduction could go towards ESG projects? What if you were able to contribute directly by doing that to the project of the quarter, for example, that somebody like Telefonica would be setting up? So this is the kind of thing that's next, I think. So the service providers are doing everything, and we're continuing to tweak and tweak and tweak and trying to find more savings. But over time, we will want to be able to get all of you to be participating in that ecosystem. I think this is one of the places that we're going.
Right. Okay. I think, long story short, I think we need to make subscribers are part of this plan, right? It just cannot happen. Operators are diligently working in reducing the energy and also, you know, bringing different kind of AI and machine learning tools, constantly tweaking the network. But now they're extremely worried how to balance the network and customer experience, right? I think the customer experience is always the key for operators. So now if subscribers become part of it, like basically in my phone, I'm seeing there's a red dot and a green dot. Just for an example, like Android has the power to do that, right? Like when we see a red dot saying that, okay, the browsing that what I'm doing is actually consuming high energy, or maybe the green dot, it shows me that I'm consuming low energy, it gives me an immediate opportunity to see how I can contribute to the Mother Earth. Right? I think that's very, very important aspect of it. So this is where we are going next. We are trying to work out to see how we can actually bring machine learning tools, analytics as part of this. So we will be happy to help in jointly collaborate with Telefonica, Nokia, and we will see the next journey as part of this. So feel free, if you have any more questions or anything, feel free to shoot out, please.
Thank you. Yeah, thank you for this presentation. Yeah, this was really helpful to learn. One question I have is, sorry. Let's say, sorry, in case of a disaster, let's say, you know, there's an earthquake or tornado or something, and let's say like, you know, in a city, 5 to 10 million people just jump on a phone and try to reach out to other people. How would that scale with what you have? Like,
Okay, we just learned that the question answers microphone is there. Actually, in this situation, the AI would not kick in. I mean, very simple as this. I mean, the network is used to the full extent. I mean, we would have to cope with other challenges, providing the right capacity to the customers. So we, in this particular situation, sorry to say, we would not care about the energy savings. We would care about the people who are desperate to reach somebody. So there the AI would go back because, I mean, also this is the beauty of the AI. The AI detects actually the capacity needs of customer. And at the moment where the network is fully loaded, the AI would decide not to switch off anything and also just to use the basic features which could still work, but not to switch off layers, not to take frequencies out, not to change maybe in the future tilting. it would make sure that you get the capacity which you need. I mean, there is no harm, but this is something where, actually this is the power of AI, because it's not static, it's not a human being doing something. So it's algorithm-based what's happening. Oh, I hope that. Some other questions. The microphone is over here.
Hello. Thanks. This is really inspiring. I work in the energy industry, so I come with an energy lens. Have you started thinking about how this can? You're speaking at it from a demand reduction side, but have you looked at how that can even impact future energy supply contracts and further savings, and even ensuring that you do reduce during, let's say, dirty grid periods, cleaner grid periods? Curious to learn a little bit more about that.
This is actually a good one. Maybe I start and then you chip in. Because I mean, this may be also different across the world. So in Europe, and particularly in Germany, energy providers are not super keen to give us special tariffs. Because one thing about mobile networks, we are rather stable in consuming energy. So actually, we are kind of stabilizing force for an energy provider. But so far, we were not able to monetize it for us. So this is one thing. But I could really imagine that we build something, because, I mean, there are also situations. I mean, we see now in some markets at certain periods of time, even negative energy prices. So we would like to use them also sometimes, but not just overpaying all the time, but also make use that there is maybe a pattern, and maybe synchronizing our pattern with the pattern from the energy provider. I think there is still something in your question, and there's still something what might come to solve maybe this problem, because for us it would be being more efficient, but on the other hand being stable and giving something back to the energy provider. I think there could be a win-win situation. Maybe you could come as the fourth partner in crime to develop something like this. But maybe I hand over to Josee. Maybe she has also an opinion on this.
Yeah, so at Nokia, sustainability is a big file for us. And scope 1, 2, and 3 are really what we're looking at. You're asking about scope 2, but we're starting right from scope 1, right? Imagine when you have a dishwasher or even a car, it tells you 8 liters per 100 kilometers is your car. This is what you're getting, right? And you have all the cars and can compare them. Well, you're not really getting 8 liters per 100 kilometers, really. It depends on how much you're driving, where you're driving, how aggressive you are in your driving, right? So what you're using is not going to be that number. So the first part to that question, I'm going to get there. So the first part to that question is about reporting actually what you're really using. This is a really important aspect, because if you just say I have 100 routers times whatever number somebody's telling me, it's not the real consumption. It doesn't match the bill. So what you want to be able to do is reporting based on configuration of the network. So that's part one of what we want to do is the scope 1 reporting. If you have reporting, you can start bringing down. You can start comparing and benchmarking, and you can start bringing down what your configuration should be and how you might want to change it in order to be able to in general, consume less. Then you go to scope 2. So now it's, okay, how are you powering this network, and how much is being consumed at different parts of your network, and be able to report on that and be able to provide some options on how can you switch different power supplies in different times. This is what, so there's a partner that we're starting to work with. So we're investigating. We're in the investigating stage for this one, for being able to bring what kind of power you would want to be able to bring in, so that we can also switch that part in. And then scope 3 we already talked about, which is the user. So yeah, this is something we're working on.
Yeah, I'd love to talk with you more about it. We do partnerships in this space, and this is exciting.
Terrific. Thank you.
All right, thank you.
Thanks.
Thanks for the very interesting session. I have a question on quantification of the energy consumption of the network overall, trying to put a bit into a perspective, where does actually the energy being consumed. So generally, what is the percentage split between the radio access network, the transport, and then the core and the cloud in terms of the consumption? And then specifically in the radio, there is energy consumption in the compute, and then in the transmission. So could you sort of size these? So where is the 10% saving out of? I know it's significant, but I'd like to get a bit more detail on that.
I mean, I will not tell the complete data, but actually the one thing what you need to remember, the radio network consumes most of the energy of a network operator. So actually it's a radio network because it's RF you're transmitting, and it's between 60 and 70% of the overall consumption of an operator comes from the radio network, because it's actually your radios. It's not even the compute, it's really your radios producing RF, unfortunately also producing heat, as we know. And this is where your energy consumption comes. And then you go to the data centers where you have another 20%. The radio network, I mean, you include there also transport, but transport is not really the big contributor. So that means this solution is really attacking where we have actually the real problem. So the real problem, transmitting, and if you transmit in a constant manner, you are transmitting and consuming the same thing at each point of time of the day. And your customers are not active at each point in time of the day.
So if you save 10% on the radio costs, you save 6% on the overall energy bill of your network, roughly.
Yeah, exactly. Yeah. Exactly. So it's really something. Super, also for us, super important. Thank you. One final question, or maybe two. We still have 5 minutes.
Thank you very much. One question, from what I understood, your presentation is around existing network. Is there a possibility to also look at the deployment of new infrastructure, positioning where to optimize based on energy source and to minimize the cost of the deployment? Or
You have an answer, also, I thought. Okay. It's an extremely good question. And actually, we didn't think about this. At least, to be bloody honest, no, because usually you place your base stations, you place them where your customer needs the base station, is the first thing. But what we do, but this has nothing to do with AI as such, what we do is chasing end-of-life topics. So for example, old technology is usually not really energy efficient, so having a proper, healthy exchange cycle in the network, those solutions, in combination with smart meters, they enable us to measure and to pinpoint where we have issues, where we should do something. Okay. It's also about sunsetting technologies. So, for example, many networks all over the world did sunset 3G already, as we did. Thinking also about what about 2G, what is coming next. I mean, but there's other problem statements, other questions. But actually, data helps us to determine where we should do something. But maybe Josee has also Naresh.
So maybe I'll add my perspective here. So when we talk about the softwares, right, I think when they go into the cloudification journey, so there has been a monolithic software from a legacy standoff perspective. Now, clearly ISVs are thinking, okay, we need to make more cloud ready, and they do a lift and shift, right? So that's how mostly they will be very compute intense, storage intense, and likewise, there will be more and more energy consumed. So that's the reason that we closely partners, with ISVs and apps, and like we go into a cloudification journey where the journey actually takes us into different methodology in terms of, how the software needs to be clearly cloudified and use more and more native services. I think we already talked about, how our TPUs and GPUs, that what we introduce is already high performance, but consuming still lower energy, right? So that portion is already taken care when it comes to cloud. But when it comes to the software, so this is where that we closely work with Nokia, and then we kind of create the journey that how effectively they can use the GCP services. In turn, they will be using less and less energy software. So that holds good for any new networks, be it OSS, be it BSS, be it network functions, likewise, right? I think it goes on and on. Like that's the journey that we are in.
I would say in general, we have a lot of planning tools on where to put the radios. And typically how the CapEx is going to be spent and where it's going to be deploying is very much based on where the user experience needs to be. So this is what probably the dominating factor, which is if, let's say I'm in an area and we're not really able to get the user experience because you're spreading your spectrum across too many people, you're going to want to be putting more So it's maybe a secondary look at. The primary is really about how do we enable the best experience for the subscribers. So this is where the CapEx is being spent. Now, if you have some choices to be able to make, like I could put it this way, this way, this way, or I can power it in these different ways, that's a different story, right? Okay. But the primary reason will be like to the user experience in general, unless you see any different, but that's...
No, I see it exactly the same way. But there's one other thing. I mean, we are standing in this nice exhibition hall now. And this is another use case because you have many locations where you have customer gatherings maybe once a week in the stadium or now this big fair kind of thingy. And there you want to have the full power in the air. But there will be other days where actually there's a bit of security here and nobody is here. And then to power it down in order to save energy, this is another use case. I mean, and this is also what we do when we talk about layer switch off using the AI, because this is something what we didn't do in the past. There was always everything in the air, but is it sustainable? Not really. No?
Excellent.
I hope it answers a bit your question.
Yes, thank you very much.
Thank you. With this, I would hand back to Naresh to conclude and close the session. Thank you.
Thank you, Telefonica. Thank you, Nokia. I think this is a wonderful journey that we are into. So if anyone have any questions, feel free to reach out offline. So we'll be happy to answer. I hope this session helped you guys to understand like where our initiatives are. Thank you.